Proposal of uncompensated centrifugal flow on accelerated cosmic expansion. Introduction. The spinning top is a rigid solid of revolution. It means that in its intrinsic rotation about its principal axis, its intermolecular bonds are sufficient to retain its particles while maintaining the distance to the axis of rotation. In other words, the intermolecular bonds compensate the centrifugal acceleration fluxes. The lathe provides the wood piece with an intrinsic rotation. Every molecule maintains its distance to the main axis of rotation. The lathe operator destroys some intermolecular bonds on the outside of the solid body. The centrifugal acceleration flow continues acting on them, but now without these bonds. Consequently, the particles are detached from the rotational domain, losing the angular momentum they had when they were part of it. So they leave the accelerational field and go on to have a purely inertial rectilinear motion, distancing themselves from the rotational axis. Each cosmic fabric constitutes a specific rotational orbital domain. It is not detached from it, it is bound to it. But unlike the rigid solid of revolution, its fabric bonds are not so consistent. This causes two effects. One, the so-called Coriolis effect, which consists of a cadence not only of the angular velocity, but also on the angular momentum for the parts furthest away from the main axis of rotation of the domain. And two, the centrifugal acceleration flux intensity is greater than the gravitational flux intensity, which causes the parts farther away from the main axis of rotation orbit to move away from it exponentially. Main. According to the theory of dynamic interactions, TID, we find ourselves in a cosmic space in which every considerable system is as isolated, it rotates, and therefore orbits indifferently of the sizes under study. With today's techniques and technologies, it is only possible to infer and know with certain precision the relatively local, isolated rotational system, such as the relative orientations of the axis of our planets or nearby galaxies, their angular velocities, etc. But at the dimensional scale of galactic clusters, we still cannot. Our present knowledge allows us to know that the intrinsic rotation axis of the Earth is not parallel with that of Saturn, nor this with that of the Sun, nor this with that of the rotation of the Milky Way, nor this with that of the rotation of the Andromeda galaxy. In this publication, it is proposed to extrapolate this fact by arguing that the cosmos should not be treated as a globality with a global axis of rotation, but that every axis is local, referring to a concrete domain of cosmic fabric. The axes of each rotational spatial domain, depending on its locality, are not generally parallel to each other. This is how the cosmos is estimated in the theory of dynamic interactions, as an astral soup of soups with matter and energy in multiple rotational orbital domains, multiple non-coaxial and non-coincident axes. It is considered that any set system that is analyzed is always local and relative, and that the idea of a global is not something that we should contemplate to seriously study nature. We do not resort to ideal inventions forced by certain observations and calculations, such as dark matter, or dark energy, and the explanation to this supposed spatial separation, accelerated between its parts, simply lies in the centrifugal flow of rotational orbital domains. This intensity of centrifugal acceleration fields exceeds the intensity of gravitational fields, with gravitational bindings not being sufficient to compensate for or retain the centrifugal flows, which is why the systems distance themselves from each other in geometric progression. If the known universe, or a section of it, is a mass of dust, our galaxy could be taken as a speck of dust within this large rotational orbital domain. In this cosmic domain, wherever our galaxy is located, our sight would perceive all other subjects or specks of dust, moving away from us in an accelerating manner in any direction in which we set our sight. In a rigid solid of revolution, as in the generality of the stars, there is an intrinsic rotation and therefore an orbiting of each one of its particles around its center of masses. The intermolecular interactions that constitute this type of systems compensate the value of the field strength of normal acceleration, centripetal, maintaining the same value but in the opposite directions as its centrifugal acceleration field strength, holding each particle with a constant distance from the axis of rotation of the system. Unlike a rigid solid, the known universe lacks sufficiently rigid bonds between its parts. The normal acceleration field's strength succumbs to the centrifugal one. The logical result of this would be that the non-rigidly bound parts of systems orbit away from their own intrinsic axis of rotation, orbital axis. Each galaxy distances its own distance to an intrinsic axis of rotation, which is common not only to galaxy clusters but to rotational orbital domains of the cosmos. Being r, the distance from the center of a particular galaxy to its intrinsic orbital axis, this r grows in the time in a rectilinear fashion, its growth rate being the constant omega square, which is the same or each and every part included in the same concrete orbital domain. This implies that each position or each particle in the cosmic fabric within that domain distances itself from any other, not in a rectilinear way, but exponentially accelerating in our local time of observation. The above is therefore a logical alternative to the proposal of the existence of dark energy, because the exponential gap could naturally be caused by a decompensation between the centripetal acceleration field strength and the centrifugal acceleration field strength. In short, the present conjecture proposes an overwhelmingly simple explanation of the accelerated separation between galaxies and galaxy clusters, and could explain at least part of the observations and experimented dated to date. Abstract. The hypothesis of the existence of the so-called dark matter arises from the observation that in spiral galaxies, the matter, from a critical distance from the galactic rotation axis, travels too fast, while the calculation illustrates an insufficient intensity of gravitational acceleration flux to explain that speed and to retain all that matter while maintaining the orbital distance. However, this hypothesis presented here that every spiral galaxy is a young galaxy, and a few billion years will be enough for all the matter distant from the center of mass of the Milky Way to remain outside the gravitational influence of the galaxy. That is to say, in this present proposal, the matter farthest from its main rotation axis is effectively lost in space as time goes by. Or, what is the same, the intensity of the centrifugal acceleration field is not compensated by that of the gravitational field, and the destiny of every spiral galaxy is a more or less homogeneous and compact disk-shaped galaxy. On the other hand, following a formal logic and evidence of the accelerated unfolding of the spatial fabric, another hypothesis is proposed. This unfolding is not caused by a dark energy, but by centrifugal fields of rotational orbital domains. The intensities of centrifugal acceleration fluxes exceed the intensity of gravitational fluxes, which are not sufficient to compensate for the centrifugal flux, which is why baryonic and exotic matter energy, space and time are extended in geometric progression with respect to our apparent time.